In Chapter 7, we're going to be talking about exponents. And most of the rules of exponents you've already learned. You've been using exponents for a few years now. But what you're going to find is we're just going to review the rules you know and then also add a little bit more to them from time to time. So today we're going to be talking about zero and negative exponents. First thing we're going to look at is zero exponents. Some of you might already know this rule. Go ahead, hit pause, copy this down, hit play when you're ready. The rule that goes with zero exponents is really easy to remember once you know it. Anything at all that's raised to the zero power, notice sometimes I have parentheses here, sometimes I don't. Typically you'll see parentheses around it unless it's something like that. This number right here probably would have parentheses around it, but in this case these mean exactly the same thing. Notice this one set of parentheses that has the negative. That would apply to the exponent also in this case, which with zero power it really doesn't matter, but with other powers it does. So the rule is that all zero exponents are always equal to the number 1. That's all you have to memorize for that. Now, as we get further into the chapter, we're going to be applying zero exponents along with other things. So you have to be aware that the zero exponent only goes to whatever it's right next to or whatever's in parentheses in front of it. So if we go through this example, 8 to the 0 power, it's 1. Negative 1.23 or 1 in 23 hundredths to the 0 power, it's 1. 4 to the 0 power, 1. 5,621 to the 0 power, 1. You could sit there all day long and plug in numbers, any number you want, put it to the 0 power, it's always going to be equal to 1. And there's a couple different ways that you can prove that this works. But the main thing to think about is if we had had 8 to the first power, then it would have been 8. So when we're looking at 0 power, it's not going to be a 0, it's going to be a 1. And at some point, hopefully we'll be able to work through some that prove this, why this works to you. The rule with a negative exponent, you're not allowed to leave negatives here. And every single year I get several students who think negative times positive, negative. And I just bring my negative down on the front and then I do 4 to the 3rd power. That's not how you're going to look at negative exponents. Negative exponents are completely different than a negative number, than a negative integer over here that we would be looking at. So when you're looking at a negative exponent, you actually need to follow the rule that in order to get rid of that negative exponent, this piece that it's next to is going to move in your fraction. If you were thinking of this as a rational number, this 4 would be over 1. The 1 would come to the top, the 4 would move to the bottom with the 3rd power. And as you move it, you get to drop your negative exponent. So that's the rule for these every time. We'll go through these 4 so that you can look at how that works. So if I had 4 to the negative 3rd power, I need to rewrite that as 1 over 4 to the 3rd power. So the part with the negative exponent drops down in the fraction. If I'd had a negative exponent in a fraction, we'll go ahead and add one down there just so you see the difference at the end. So it just moves down in the fraction and now it becomes a positive exponent. Sometimes you're just going to leave these like that, 1 over 4 to the 3rd. Other times you might actually multiply it out, 1 over, and now you have to figure out 4 times 4 is 16. 16 times 4, 64. So it would be 1 over 64. So go ahead and look at this one. We do the exact same thing. 3 to the negative 4th power. When I see that negative exponent, I'm going to go ahead and bring 3 down to the bottom to the 4th power. I get to lose my negative exponent. And then same thing, I can multiply it out now, which equals 1 over 3 times 3 is 9, 9 times 3, 27, 27 times 3, 81. So 1 over 81. Okay, this one. Be careful because this whole piece is going to drop to the bottom since it's all in parentheses and you have a negative exponent there. So 1 over, and I keep my negative 4 in parentheses because I need that negative to stay with that exponent, to the third power. Now, what you're going to find in this example, if you've done really well with your exponents, is that in this case it's not going to matter because if you remember the rule for odd exponents, negative times negative times negative is still going to leave you with a negative. But if this had been an even exponent, that negative would have needed to cancel. So that's why it's really important to leave the parentheses around it till you're ready to simplify. So now we end up with 1 over negative 4 times negative 4 times negative 4, which is negative 64. And let's go over one more of these. Now in this one, negative isn't in the parentheses, so negative can actually stay at the top of the fraction, become a negative 1 over 3 squared. Hopefully you all noticed why I left the negative alone. It wasn't in the parentheses, it doesn't go with the squared, it's not going to cancel. And then I get negative 1 over 3. Remember, a lot of mistakes here. 3 times 2 would be 6, but this is 3 times 3, which is 9. Now I'm just going to show you actually 2 more. We'll do 2 more. If I had 3 over 4 to the negative 2. I'm just going to show you how this works right now. It's going to come up again later, but hopefully it'll help you see how these can flip around in the fraction. Because I have the negative, 3 is going to move to the bottom and become squared, and 4 is going to move to the top and become squared. So I end up with 4 squared over 3 squared. And 4 squared is 16, 3 squared is 9. And similar example, if I had something like 1 over 3 to the negative 2. 3 to the negative 2 would move up and multiply to 1. So it ends up being 1 times 3 squared over 1, because there's a 1 left over under there. And we end up with 3 squared, which equals 9. So if it's in your denominator, it's going to move to your numerator. If it's in your numerator, it moves to your denominator. All these first examples were all numerator. They were just integers. Write this down. Once you're done writing this down, hit play and we'll continue. In example 2, we're just looking at more of the 2 rules we went over, but starting to kind of combine them together and have more stuff going on with the problems. So write down A through E's examples, hit play when you're ready to go through them. When we're looking at example 2, we have to be very aware of parentheses and not having parentheses. It's when this really becomes important to understand. This is a product, 4 times y times x to the negative third power. The x to the negative third is multiplying to 4 and y. Negative third power does not go with the 4 or the y. It would if there were parentheses around it, but there aren't. So if you're having trouble seeing that as we go through this chapter, I would start spacing these apart a little bit and putting a little dot inside for showing multiplication until you get really good at recognizing that. Which means in this example, all we're looking at is that needs to move right there. And you just learned the rule, it needs to move down because currently it's up in a numerator of a fraction. So 4 and y would stay where they are, and then x would move down and become a positive exponent, and you're done. There's nothing else that could be simplified here. So go ahead and look at the next one. We did an example like this already. 1 can stay where it's at. W to the negative 4 needs to move up. 1 times w to the 4th is w to the 4th. And you're done. Look at the next one. Okay, again, 11 times m to the negative 5. The only part that you want to look at moving is that part right there. 11 stays where it's at. M moves down to become a positive exponent. And the rule is we never show answers with negative exponents, so you always take this step and simplify them when you get negative answers. Now, I went ahead and wrote the exact same thing, but with parentheses, just to show you the difference if you're confused about that. Here, this whole piece needs to move down because it's all to a negative exponent. So 1 would stay at the top. 11m to the 5th would move down. And in this case, I'm not going to be asking you to multiply out 11 times 11 times 11 times 11 times 11, but you should all recognize that 11 5 times multiplied by itself 5 times is what that's representing. So if we're looking at E, again, just go through it. This is what I have to move. This is what I'm focusing on. 7 stays, t squared stays. S to the negative 4 moves down to become a positive exponent. And I'm done. Nothing else simplifies. Now as we go further into the chapter, there might be things that actually simplify between your numerator and your denominator that you'll check for. Write down F, G, and H and hit play when you're ready to continue. So here, and this is where a highlighter might be helping some of you, just highlight the things that you need to take a look at. Okay, 2 is fine where it's at, but a to the negative 3 I need to make positive. Oh yeah, if I move it up into my numerator, then I get a positive exponent. 2 times a cubed. They're multiplying together when I move it up. Okay, when I get to G, same thing. V squared doesn't need to move, but I notice that negative exponent needs to move. I have nothing left at the top, which means I put a 1 there. Because it really isn't a 0, it's when that moves, there's a 1 left there. I have v squared, and then I moved n to the 5th down. Positive exponent when I move it. Okay, last one. I see an x to the negative 2 I need to deal with, and I also see a y to the 0 I need to deal with. So I end up with 4 times y to the 0 becomes a 1, right? Over a, and then I moved x down, and it became squared. And we all know 4 times 1 is 4, so my final answer is 4 over ax squared. Only reason I put this times 1 here is just to show you what happened to that, in case you're looking back later and confused. Typically, I would have just made that a 1 and realized right away 4 times 1 is 4. Write this down on the left side. It's just explaining what we were doing. We're following the negative and 0 rules for exponents to simplify these. And just be really aware of your parentheses and when there are no parentheses like this one, because that does change your rule. Write this example down and hit play when you're ready to go over it. There are several different ways you can approach evaluating, but I'm going to tell you that my recommendation to you is I have found it much easier for me to always simplify my original expression before I start plugging in values for my variables. This negative 2 right there, I can simplify that by moving it using the rules we just learned. If I had something to the 0 power, I could simplify that. Do all that simplifying before you start plugging in numbers. It makes life so much easier when you go to solve these. So we'll go ahead and write our original expression down, which was 3m squared t to the negative 2. And I'll show you what I mean by simplifying it first. Do exactly what we just did in examples 1 and 2. I see this negative exponent that I want to deal with, so I'm going to go ahead and deal with that. And I end up with 3m squared over t squared. Now I don't have any negative exponents to think about, and I'm not accidentally going to multiply these negatives and get a positive either. Okay, once you have an expression to use, now you're going to evaluate. Don't forget, use parentheses. You have to use parentheses when you plug in values. Otherwise it changes things. So I have 3 and m is equal to 2. So I'm going to plug in 2 squared over t, which is negative 3 squared. When you're going from this next step, common error. People want to multiply here, then square it. You need to remember order of operations. Exponents come before multiplication. Such a common mistake, and it's such an easy one to make. So if you make that, then I would put a times sign there so you think about that. Now you end up with 3 times 2 squared, which is 4, over, this is where those parentheses came in handy, because it's a negative times a negative, which is positive, 3 times 3, which is 9. If you did not put parentheses around that, then you should have had a negative 9 there, if you were following the rules correctly, and that would make it wrong. That's why it's important to use your parentheses when you're evaluating. So now I end up with 12 over 9, and this can simplify to 4 over 3. So when m equals 2 and t equals negative 3, my answer is 4/3. Write this down on the left. It's exactly what I talked about. Always simplify the expression before you evaluate. That was this first step we took here. And then always use your parentheses and follow PEMDAS, order of operations. Hit play when you're ready to write the rest of the examples down. Write these 4 expressions down, and then you're going to evaluate them when n equals negative 2 and w equals 5. If you think you can do this on your own right now, go ahead and try exactly what we were doing, and then hit play when you're ready to check them over. If you're still feeling a little unsure of what you're doing, go ahead and just follow along with me right away. So again, remember, always look, is there anything I could do to simplify this before I even start plugging in values? I notice that I have n to the negative 3rd I'm going to need to move, and I notice I have a w to the 0 power. So when I look at this, and I go to rewrite it, w to the 0 power becomes a 1, n moves down and becomes a positive 3rd power. Now I go ahead and evaluate. Notice I don't even have to plug in anything for w now. So when I go to evaluate, 1 over negative 2 cubed. Now on these, you should all know negative 2 times negative 2 times negative 2. So when it's a smaller number like that, I do expect you to multiply it out at the end. The book is very jumpy about when it decides to multiply them out and when it doesn't. So just make sure that when you're checking your answers in the back of the book, you're checking it the way the book has it to make sure that it's the same. On your test, I'll be very specific about when I want it multiplied out and when I don't. But anytime you see something small that you know you can do mentally, you should always do that. So I have 1 over negative times negative times negative is a negative. 2 times 2 is 4. 4 times 2 is 8. So negative 1/8. Okay, go to the next one. This is what I see that needs to be moved around. It's going to drop down. So I end up with 1 over n to the 1st power. Now, n to the 1st power, I can go ahead and drop that 1st power. I'm going to leave it for this part, but anything to the 1st power is just the number. So you really don't need that 1st power anymore. You needed it here because of the negative with it. Equals 1 over n is negative 2. I'm going to drop my 1st power. W is squared, which is 5. Now I end up with 1 over negative 2 times 5 squared, which is 5 times 5 is 25. So my final simple or evaluated solution here is 1 over a negative 50. Okay, negative 2 times 25 is negative 50. Be really careful when you're switching between multiplying and doing exponents, because sometimes it's really easy to accidentally mess that up. All right, when you got to C, this is what you should have noticed could be simplified before. And W is 0 power, again becomes a 1. Makes my life a lot easier because now I just have 1 over n to the 4th. So I plug in n, I get negative 2 to the 4th. 1 over negative 4 times is going to be positive. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So positive 1 over 16. And if you have any questions about what I'm doing right now, write down your question over here so you can ask me in class. D, that's what needs to move. It's going to move up because it's in the denominator now. So I get w squared, 1 times w squared is just w squared, over n. And then I go evaluate, my w is 5, so 5 squared, my n is negative 2. 5 squared is 25 over negative 2. For example 4, I'm just going to go over it with you. If you want to go to your book, you can. It's page 330. It says, a biologist is studying green peach aphids, like the one on the left. In the lab, the population doubles every week. The expression 1,000 times 2 to the w models an initial population of 1,000 insects after weeks of growth. So it's doubling every week to every week. Evaluate the expression for w equals 0. Then describe what the value of the expression represents in the situation. Remember, the rule for 0 is it becomes 1. This kind of proves why that 0 power works. The starting population was 1,000, and 1,000 times 1 is 1,000. So at week 0, we're starting with 1,000. The value of the expression represents the initial population of insects. This makes sense because when w equals 0, no time has passed, which is what I explained. Then it asks you to evaluate the expression for w equals negative 3. Okay, if you're thinking about negative 3, what that should mean is it should be a smaller population. It means the population has been doubling every week, but this is before. This is 3 weeks before we got the aphids. So you plug into the negative 3rd power. You end up with, remember, this becomes 2 to the 3rd power at the denominator of a fraction, which is how you get 1,000 times 1/8. And when you simplify 1,000 over 1 times 1/8, you get 125. So there were 125 aphids 3 weeks before you started with your 1,000, before you even got them. So you're going to come across things like this where it's a real-life application that's kind of proving why these negative exponents work and why these 0 exponents work.